In this section, we are going to be looking at subtle ways that organisms interact, starting by looking at adaptations. You should recall that within an ecosystem, the biotic and the abiotic factors interact. If there is a change in either of these conditions, a population will need to adapt to the change, or they can leave, or they will die out. An adaptation can be defined as any genetic trait that improves an organism's chance of survival. Chance. It improves its chance of surviving and reproducing. So it improves its chance of passing its traits on to the next generation. Organisms that are adapted will be able to survive changes in conditions better than others. Nature will then favor these organisms, these adapted organisms, and eliminate those individuals that are poorly adapted. This process is called natural selection. And I want to change this from organisms that can adapt to organisms that are adapted. Because it's important to note that organisms don't adapt. A population adapts. Because these adaptations are genetically based, an individual organism cannot change its genetics. But an organism that is suited to its environment may survive and pass on its genetics to the next generation. So natural selection, I want to say those that survive will pass on their traits. Those that survive pass on acquired traits. And as a result, the population as a whole will change. I want to show you a famous example of adaptation. This is the peppered moth, and the peppered moth exists both as a light color and as a dark color. So it can be of two different forms depending on what genes it gets, light color or dark color. And the peppered moth has been very well studied for the last couple hundred of years. Peppered moths usually are the light form. And it used to be that when the pepper moths lived on their trees, this one over here on the left is what the trees used to look like, and what the trees look like in a healthy ecosystem. These trees are all covered in lichen, and you can see that the dark moth really stands out, whereas the light-colored moth blends in. These moths are preyed on by birds, so birds are going to be much better able to grab the dark moths than the light ones. So this would select against the dark-colored moths. They would die, their genes would not be passed on, and you have mostly light-colored moths. After the Industrial Revolution, there was a lot of pollution in the air. And this time, the dark-colored moths were better suited. The light-colored moths were easier to see. So then there was a shift in the population, and most of the pepper moths were of the dark-colored variety. After the air was cleaned up, it went back to the light-colored being the most popular one. Adaptations can include things like camouflage. So for example, the Arctic hare or the Arctic fox have white fur so that they blend in with their environment. Adaptations can include mimicry, when one species resembles another. Sometimes if one species is poisonous, another species will adapt to resemble that one so that predators think it is poisonous as well. And coevolution. This is the adaptation of two species in response to each other. Predator and prey often co-evolve. It's an arms race. The prey may evolve to be better camouflaged, and then the predator may evolve to have better eyesight or to be faster, and so on. Next, we're going to be looking at biodiversity. Biodiversity means the variety among living organisms within an ecosystem. So the variety of and among organisms within an ecosystem. And biodiversity is closely linked to primary productivity. Primary productivity is a measure of the available energy that is provided by the producers. So a measure of the available energy provided by the producers. It should make sense that areas with high primary productivity will have high biodiversity. Here we live in a temperate rainforest and we have a high primary productivity and we also have a high biodiversity. Areas with a low primary productivity will therefore have a low biodiversity, not very many different kinds of species. These types of ecosystems with low primary productivity and low biodiversity are really fragile. The loss of even one species can greatly affect the ecosystem. Sometimes this can lead to both extinction or extirpation, or both. So extinction is when a species completely disappears from Earth. So when a species is gone completely from Earth. This is different than extirpation, which is when a species dies out locally. So it's local extinction. If that was the only place that that organism lived, then it would be extinction. But often it's just extirpation, so it's local extinction, where a species no longer exists in one area, but it may still live elsewhere. So a species no longer exists in one area. The last thing we're going to look at in this video is a keystone species. And a keystone species is a species whose presence plays a very important role in an ecosystem. If you're not familiar with the term keystone, this is a keystone. I can't write on this page, but this is an arch. And imagine this arch is built out of bricks. And this is the brick that holds everything up. If you removed that brick, the whole arch would fall down. As long as that brick is in place, everything else will stay. Same thing with keystone species. So a keystone species is a species whose presence plays an important ecological role in determining the types and numbers of other species. Here in BC, one of our important keystone species is the sea otter. Here's a sea otter, and the sea otter is feeding on some urchin. Sea otters eat a lot of urchin, and that's very, very important, because if sea otters weren't there to eat the urchin would grow out of control. The urchins eat the kelp. If the urchins eat kelp, then the whole ecosystem is going to collapse. If the urchins eat too much kelp, if they're out of control.